My dear friends, welcome to SEKAR classes on Applied Data Science with Python. This is lecture number 98. In this lecture, we will try to understand discrete random variable and continuous random variable. In my previous lecture, I discussed about random variable. Now, we will try to understand discrete random variable. Let us see an example. We will start with tossing coins. I want to know how many heads I might get if I toss two coins. Since I only toss two coins, the number of heads I could get is 0, 1 or 2 heads. So I define x. This x is random variable. I define x to be the number of heads that I could get. Isn't it? What is x here? X is number of heads in tossing two coins. Just see here. If I toss two coins, what are the possible outcomes? You may get two heads like this. Isn't it? You may get two heads. Head, head. How many heads in this particular outcome? There are two heads. Therefore, x equal to. How many heads in this particular outcome? There is only one head. Therefore, x equal to 1. How many heads in this particular outcome? There is only one head. Therefore, x equal to 1. Here, this one. How many heads in this particular outcome? 0 heads. Why? Because there are these two are tails. Therefore, x equal to 0. This capital X represents random variable. If you speak strictly, it is a discrete random variable. In this case, each specific value of the random variable x 0, 1 and 2 has a probability associated with it. When the variable represents isolated points on the number line, just see this one. This is isolated points. This is one point. Just see, this is a point, this is a point, this is a point. Let me say this is 0, this is 1, this is 2. Isn't it? They are isolated points. There is a gap in between 0 and 1, 0.5, 0.6. There is a gap in between 1, 2, 1.5. Isn't it? If there are let me repeat. When the variable represent isolated points on the number line, such as 1 with 0, 1 or 2. That is discrete random variable. Discrete means there must be a gap. It is opposite to continuous, isn't it? Discrete random variables represent isolated points on the number line, isn't it? A discrete random variable is a variable that represents numbers found by counting. Isn't it? 0 heads, we are counting. X equal 0 means 0 heads, x equal 1 means we counted. X equal 1 in this case, we counted. We are counting. X equal 0 heads, 1 heads, 2 heads by counting. Isn't it? Therefore, I can say discrete random variable is a variable that represents numbers found by counting. For example, number of marbles in a jar. That is discrete random variable. Number of marbles may be 1, 2, 3, 4, 5, 6. You cannot have 10.5 marbles. You cannot have 7.8 marbles. Isn't it? Another example is number of students present. Number of students present. That may be 10, 11, 12. You cannot have 10.5 students. Isn't it? Therefore, that is discrete random variable. Or number of heads when tossing two coins. This I already discussed. Tossing two coins experiment, we already discussed. What is the random variable? X represent number of heads. If x represents number of heads in tossing two coins experiment, that x is a random variable. Which type of random variable? Discrete random variable. Why? What is the reason? X can take 0, 1, 2. Isn't it? There is a gap in between 0 and 1, 0.5, 0.6, 0.1. There is a gap in between 1 and 2. These are discrete. This random variable is called as discrete random variable. As I told you, each possible outcomes of a random experiment is associated with some probability. The number of heads that can come up when tossing two coins is a discrete random variable, because heads can only come up a certain number of times, 0, 1 or 2. Also, we want to know the probability associated with each value of the random variable. As I discussed, this 0 heads, how many possibilities? Just see 0, 1, 2. Here, let me discuss here itself. What are the possible values for x random variable? 0, 1, 2. What are the probability for 0? 0 means 0 heads. How many favorable cases are there? 0 heads means there is only one favorable case. How many total number of cases? There are 4 cases. My probability is 1 by 4, isn't it? What about getting one head? One head means what are the favorable cases? There are 2 favorable cases, this one and this one. Therefore, one head means favorable to total 4. 2 by 4 means 1 by 2. What about getting 2 heads? 2 heads means how many possibilities? There is only one possibility, that is favorable 1, total 4. 1 by 4 means it's 0.25. This is also 0.25. 2 by 4 means that is 1 by 2, 0.5. 0.25 plus 0.5, 0.75 plus 0.251. Sum of all probabilities is equal to 1. Isn't it? Yes. This means, that's what I told you. Each value of random variable is associated with some sort of probability. That's what I discussed. 0, 0.25, the x equal 0 means probability is 0.25. Isn't it? X equal 1 means 0.5, x equal 2 means 0.25. Isn't it? In this table, you will notice the probabilities 0.25, 0.5, 0.25. These are the probabilities. We will see how to calculate the probabilities associated with each value of the variable. However, what we see above is called probability. This point is important. Probability distribution for the number of heads when you toss 2 coins. This is probability distribution. In last lecture, I discussed about different probability distribution. We discussed the introduction to probability distribution. This one is probability distribution. This is explaining how probability is distributed, isn't it? Is it not explaining distribution of probability? Therefore, it is the probability distribution for the number of heads when you toss 2 coins. A probability distribution has all possible values of random variables. These are the possible values of random variable. X represent number of heads, 0, 1, 2. That's what it says. A probability distribution has all possible values of random variable and the associated probabilities. Yes, this point is important. Probability distribution must have all possible values of random variables. These are possible values of random variables and these are corresponding probabilities. This entire table, I can say probability distribution for the number of heads when you toss 2 coins. This is discrete probability distribution. Now we will try to understand continuous random variable. Suppose I am interested in looking at statistics test scores from a certain college from a sample of 100 students. Well, the random variable would be the test scores, which could be range from 0%. 0% means did not study at all, to 100%. 100% means excellent student, isn't it? However, since test scores vary quite a bit, I will repeat. However, since test scores vary quite a bit and they may even have decimal places in their scores, I can't possibly denote all the test scores using discrete numbers. So, in this case, I use interval of scores to denote the various values of my random variable. When we have to use intervals for our random variable or all values and interval are possible, we call it a continuous random variable. Therefore, continuous random variables or random variables that are found from measuring like height of a group of people or distance traveled while grocery shopping or student test scores. In this example, we discussed student test scores. Student test scores can have any percentage. It can take decimal values, isn't it? That may be 76.5, that may be 40.2, that may be 90.5, that may be 0%, that may be 100%. It can take decimal values. Therefore, that is known as continuous random variable. As I told you, height of a people, height may be 10.5 feet, 6 feet, 5 feet, 5.4 feet, 4.1 feet. It can take decimal values. If it is taking decimal values, means I can say it's a continuous random variable. Even we were saying that distance traveled while grocery shopping, that distance may be 10.5 kilometers, 10.1 kilometers, 6.2 kilometers. It can take decimal values. Therefore, I can say it is a continuous random variable. As I told you, student test scores may be 90.5, 65, 65.6, 78.2, 99.1. It can take decimal values. Therefore, student test scores is also an example for continuous random variable. In this case, x is continuous because in this example, student test score example, x is a continuous because x represent an infinite number of values on the number line. Just go through this. This is simple lecture. If you have any difficulty, just keep a comment. We will discuss. Thank you very much.